In this lecture, we're going to learn about overflow and underflow. And this is something that happens when we try to fit much more that can fit in a variable, or if we try to put in less that can actually go in that variable. And what do I mean? Suppose we have a 1-byte variable. We know that if we are putting in positive numbers, this variable can store values between 0 and 255. What if we do something like this? What if we have an unsigned character called var? Inside we have some valid number, but we try to store in something much bigger than 255. We have two numbers here, 130 and 131. If we add them up and store the result in var and try to print this out, what do you think we'll get? If we add these up, we're going to get 261, which is much larger than 255. So data is going to overflow because we try to put in much that can fit in a var, which is unsigned. And if we print this up, we're going to see some garbage value. But I want to shed some light on how we get to this garbage value because it has to do with how internal computer circuitry is wired up. Here we have a simple illustration of how overflow works in a simple computer circuitry where we have a piece of 1 byte. So we can store in things from 0 up to 255. Here we have a mapping between binary and decimal for the values we store in. And we can see that as we grow and hit 255, whose binary representation is all ones, and if we try to increment this, the computer circuitry is going to flip off all the bits and we're going to get to a 0. If we keep incrementing, we're going to start the cycle again and we're going to start and go from 0 all the way to 255. And if we keep incrementing, the cycle is going to go on again. I really hope this makes sense. So what is really happening here is if we count and get to 255, if we go to 256, we're going to flip all the zeros and we're going to start from 0 again. And we're going to have a situation like this. We hit 255 and we started over again and go to 0, 1, 2, 3, 4 until we come here again. And if we overflow again, we're going to come to 0 and the cycle is going to keep going on like this. This is what we call overflow in computer circuitry. When we hit the maximum value that a type can hold, we are going to restart from 0 because we can't really represent much more than that. So the computer is going to do the best it can. It's going to say, I can't really hold this much. Let me go back and start from 0 because that's how they work internally. That's the behavior they have that is built into them. Underflow really works the same way, but we will go in a different direction. If we take val1 and minus val2, we're going to get a -1, but we can't really represent a -1 in an unsigned character, because an unsigned character variable is only going to store data between 0 and 255. So what we're going to have is a situation like this. If we hit 0, which is all zeros in binary, if we try to go to the left and store in something less that can really fit in here, we are going to overflow. And the circuitry is going to try and use 255, which is really not what we want. We want a -1. But the best the computer circuitry can do is flip over and start from the top and go from 255. And if we keep decrementing, we're going to go to -2, -3, and it is going to be a binary representation of these numbers here, 253, 252, 251, and we're going to keep going down. And if we hit this location again, if we hit 1, 0, -1, the cycle is going to start again. Okay, this is what we mean when we say that we have an underflow or an overflow in our operations. Okay, here we have another example. That is really what we had before, but data is put in directly. 251 can't fit in a car, so we're going to overflow, and we are going to have a binary representation of how many times we have passed over 255. And if we have a -1, we can't really store it in an unsigned car, and we're going to have an underflow. Okay, now I hope you have an idea about how overflow and underflow work, at least for integers. But I also want you to see that overflow and underflow are not limited to integral types. We have used unsigned char because it is easier to show there, but we can have the same phenomenon. For example, if we try to store more than can fit in a float or double, and we're just going to get garbage data, but the rules are going to be much more different because the way we transform from floating point to the representation in memory is different from how we do that for integers. As a general guideline, always be mindful of the valid ranges for your data types. Don't try to put in much more than can really fit in there. And we have seen how to use the numeric library to really get this information in an easier way. Sometimes the compiler will help you out, but you can't really rely on this. So be extra careful in what you store in your variables. Okay, I think this is enough theory about underflow and overflow. Let's head to Visual Studio Code and actually see this happening in our code. Here we are in our working directory. The current project is Overflow and Underflow. We are going to copy our template code and we're going to put that in the project here. And we're going to open this up in Visual Studio Code. We're going to open up our main file and we're going to remove whatever it is we don't need. And we're going to explore what happens with overflow. What we're going to do, we're going to set up an unsigned char variable. Let's call it data. And we're going to put in a 250. Let's do that. Why not? And what we're going to do, we're going to increment data and print the value. So we're going to say stdc out data is data. And we're going to do this a couple of times. So by this time, we should have a 251. And if we do this again, we're going to have a 252. So let's go down. 252, 253, 254, 255. We have hit the top range of what we can do. If we increment again, we're going to fall out of range. But before we get there, let's try and run this program and show you what is happening. I really want you to see this. Can we hover over this and know what data is in here? No big deal, we can build this. So we're going to run the task to build with GCC. And if we run this, we're going to see that the data is shown. It is actually trying to print characters. So what we need to do is to convert this to integers because that's much easier to show here. So what we're going to do, we're going to say static cast. We're going to cast this to int, and we're going to put this in parentheses like this. We have seen how static cast works, and here we need it, so we're going to use it. We're going to paste this in here a couple of times, and we are going to build again. Let's do that. Run the task to build with GCC, and if we run this, we're going to have data starting from 251 all the way to 255. So what could happen if we incremented this and made it a 256? Let's see. Let's make sure we have this noted out for whatever it is we have in our data. So we're going to go down a little bit and increment again. So we should have a 256, but we can't really represent this number in an unsigned char piece of data. So we're going to have overflow here. So what we're going to see, let's try and run. The build is going to go through. We're not going to get a compiler error, but you see that we have a 0. Why is it this case? Here we can try and print the data in hex, and it is going to make it much easier to see what is happening here. So we can do std hex as a manipulator of how we want to see the data. And the same manipulator is going to stick and be used here, so we don't need to reset it again. But when we are done, it is a good idea to reset it to std_dec because that's what people expect by default. So if we build and run, we're going to build with GCC and run this. We're going to see that when we hit 255, it is all Fs, which is really an equivalent for all ones. But when we increment again, we're going to overflow and things are going to start from 0 again, which is what we saw in the slides. We can see the same version of things if we try to decrement something that is close to 0. So if we go down here and say data equals 1, for example, and we decrement data, Let's go down and do that. And we're going to minus minus instead of plus plus. So if we do that, we're going to get a 0. But if we minus minus again, we're going to underflow. And what we're going to have in our data is 255. I want you to see this. So let's run and make sure you really see this. We're going to build with GCC. The build is going to go through. Let's clear out of this and run. So you see that data is back to 255 after we decrement from 0. And this is underflow in action. I really hope you see what is happening here, and I want you to be mindful of this, because if these kinds of overflows and underflows come up in your program and it is really not what you expect, these errors can be really hard to find and solve. So be aware of this. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.